Actually, what is integral? I mean, what is integration? Do you know anything about this? So, if I write, suppose for example, like this, f of x into dx, by observing this, you can say that it is integration. This symbol is integration of f of x dx. Okay, then here we can say that integral of f with respect to x, correct. And many of the applications are there, many users are there, so we will see about this what is integration. Okay, so actually integral tells us that area enclosed. What it says, it says that what area, about area enclosed. Okay, that about we will see what exactly it is integral means. See, you know what is this, it is a rectangle. So if I tell you to find the area of this rectangle, you can find out very easily. Suppose if I give this square, then also you can find out very easily. If I give the circle with radius, you can find out the area of this one very easily. If I give like this a triangle, it is a right angle triangle, you can find out the by using the formula half into base into height, correct. And if I give like this safe, then also you can find out the area of the given figure, or the area which is shaded region from this figure 2D shape and all, you can find out very easily. But suppose the diagram is like this, these are all well shaped, these all diagram which I have done here, they are all well shaped. Okay, suppose for example, if I give you like this, then I think it is not well shaped. Okay, uh, for this one there is no particular shape, unshaped region here, the shaded region is unshaped region. So we need to find the area of this shaded portion. Suppose if I give like this shape, and if I tell to find the area of this one, so these are all unshaped region, these are all what, unshaped region. So for this we don't have the particular formula to calculate the shaded portion here. So for this we use integral, we use integral. It will very useful to find the area, shaded area from this unshaped region. Okay, so particular, if form is not there, if particular shape is not there, then you can use integration, and then very easily you can find out the area which is which we are required. Okay, so for example, think that there is a rectangle, and I told you can find out the area of this rectangle very easily by using the formula. Okay, suppose for example it is like this, one river is moving from here to here, and this is the rectangle, like this it is moving. So if it is a rectangle, you know how to calculate the area of the rectangle, but in between the shape of this one, both side the river is moving like this, so water is there, full of water is there. So this shape of rectangle is changed here. At this time you cannot use the formula of a rectangle here. So here the shape is completely changed, it is unshaped. Before it was rectangle, but when a river came moving from here to here and here, so the shape of the rectangle is changed. So here curve, you will get the curve here. Okay, you will get the curve. So for that one we can use the integral, that integration, and you can find out the area which is here which we require, that is shaded region. You can say area enclosed by this one, you can say. Okay, that it will be very useful, that if you use integration we can find out the area for the unshaped region or unshaped figures, you can see. Okay, I think you are getting what I am going to tell. Okay, now you can see here there are two graphs here. So this is one curve is there, this is also one curve is there. So I will do like this on x-axis, and I will give the name A and B. Similarly here also I will do from here to here and here to here. So this is A, this is B. From A to B area we need to find out this area, this shaded region we need to find out here. So I think you may be thinking that why sir has done like these two graphs. So think that he is a person 1, so his name is A and his area is this much. Okay, this is own plot. Think that this is a plot. So this plot is of person A and he is selling this plot to B. Okay, suppose if you are selling from here to here, suppose you are selling this plot to him, that person name is B. A person is selling the plot to person B. So that to sell this plot, you must tell, A must tell to B about first one is rate, second one is exact area, how many square foot is there, 100 square foot, or what is that, 1200, 1000, 500, okay, 600, 800, 150, whatever it may be, he must tell, A must tell to B. But what is the thing is that here here it is unshaped region, you cannot tell this one. Okay, so there is a supporter A1 to A supporter. A1 person is there who is one more mathematician. He is a mathematician. Think that he is a mathematician. He is going to help the person A to find out the area. Okay, so he will make, now that from here to here I can make rectangle. So this is the rectangle and he can find out the area of the rectangle very easily by using the formula. Okay, so here also he can say that from here to here we can make, so this plot rectangle area he will calculate and he will tell the rate, and he will he is trying to sell the plot to the person B. Now one more supporter is there for B1, like for A1 supporter was there, so for B1 supporter is there, so he is also a mathematician, so now he will tell that this B1 mathematician says that, see, we are having the plot from here to here only this much, why we need to pay extra amount for this one? For this one there this much area will be extra, na? If he do like this and if we calculate the area of this rectangle, it will be more than this, whatever the original plot is there, whatever the area is there for the original, it will be more. So B1 supporter will tell, hey, no, we are in loss. So again another A2 mathematician will come and he will help to him. Similarly for B2 mathematician will come and help to calculate the area. So let us see how they will calculate. Okay, now see here, first A1 did like this square and it was having the error. So again A2 modified the same area, this area he modified like this. So again compared to the above graph, compared to this graph, the error is lesser here, so he is nothing but A2, he is giving plan like this and A2 will give like this. Okay, so now the error of this one is lesser than the previous graph. Okay, so now he is doing like this. Now what he will do, B2 will do, again give the idea. So again we are getting more area here, so what he will do, instead of like this, he will do in the different way. He will do like this here, and this is the curve from here to here, so he will mark like this from here to here and here to here. So he is trying to get the rectangles above the curve and he is trying to get the rectangles below the curve, Okay, similarly again here B1 I told na, so it is above na, so he can give like this much, B this much you can take so not this one, only this much you can take. So this is lower below the curve we are giving. Suppose if you are calculating this area, this much extra area will remain here na. So in the same way here A2 will support to calculate the area like this, and here B2 will support to calculate the area like this. Similarly again you are having the error for here, B needs to pay more for this area, here he is getting loss. In this case A is getting loss, and in this case B is getting loss. Okay, this is A, this is B. Okay, now for this one, for again A3 and B3 two person will come, mathematicians will come, and again they will do like this. See here, this is that one, this is the curve. So here only two rectangles were there before, so he will try to make again more rectangles here. So like this again he will make, okay, he will try to make like this more and more rectangles. So here B3 also he will try to make like this rectangle. This is the curve, like this he will make like this more below the curve like this. So like how much more rectangles they are finding, the error is going on lesser. Okay, in the first case here the area was more and B1 has to pay more money here, but here as going on A2 parts, how much rectangle parts are making more, n strips. If you call this one strip as a rectangle, how you are making more strips, more rectangles, you will get the less error. More number of strips means here rectangle, more number of strips, less error, correct? So less error. If you make more n number of strips, then somewhere these two will become equal, correct? So suppose this is A, this is B, A to B. Okay, so here lower means actually below the curve means this is nothing but we are taking, this is lower integral. Lower integral means it is denoted like this, and it is above the curve we are making the strips means this is upper integral and denoting by like this. This bar will be upper side, here bar will be to the lower side. So this will be very important. As you increase the number of strips more, the less error you will get. Then somewhere both will be correct. Then A can sell the plot to B, and he will also not get loss and he will also not get the loss. Both will be in proper, both will be correct. A somewhere this will be equal to this one. Okay, so both will upper integral and lower integral, both will somewhere it will be equal to same, like this one graph if I take, and somewhere it will be equal like this. So for this shaded region it will become equal by less error. So whatever the less error is there, the distance if it is too small, you can neglect that one, negligible area. So this will be equal. So somewhere if you make n number of strips, you will get the area as what you are going to sell. A is going to sell this much area only. So this is nothing but your integral. This is nothing but your integral. So it is difficult to find out the area which is shaded by the integration method. So we are making the n number of strips so that you can calculate this rectangle, this rectangle, this rectangle, this rectangle, this rectangle, the area, and then you can add all these areas. Why did I give the name supporter as A1, A2, A3 means as n strips, that is 3 strips, like that n strips if you make, then the value whatever you want the area to be calculated, that will be easier here. But in the graph before, when A was selling to B, it was not balanced, no balance, it was not balanced the area. When A1 supported and B1 supported, then the same thing, like this A2 supported B2, then also no balance. When A3 supported B3 mathematician, then also no balance. Somewhere EAN will support to calculate the area, and then it is balanced. Then it is balanced. Some number of strips are more, then it is less error will be there, but it will be negligible. It will be negligible. Suppose if I write 100.0000000000005, then you can neglect this one and you are writing 100 na. So some area will be approximately whatever you are getting the area here, what you are going to calculate the area na, that will be approximately nearly equal to the given value. Okay, whatever just we have learned, that is nothing but this one, integration of some function of x with respect to x, which we are calculating, that is integration of f of x dx. Here integral sign, this integral sign came from, this is integral, we will call this as a integral, and this symbol came from the word sum. Okay, this one, it means this integral, this symbol means, this symbol is nothing but, you can call this as a summation. What we are calling this as a summation. Actually this integral tell us how much something is accumulating. For example, downloading a movie, in 1 minute something data is downloaded, movie is downloaded, in 2 minutes, 3 minutes, like that. It is like the graph between instantaneous speed and time. So actually data accumulated in downloading the movie is nothing but, data accumulated is nothing but area enclosed. Data accumulated, for example, accumulated is nothing but what, area enclosed, you can say. So like this we can use the integral and you can find out all this one. Okay, so in all cases when the straight lines are there, you can find out very easily the area bounded by the curves, but when the area bounded by the curves is there, then it is difficult. So n number of strips you are making rectangle and you are find out the area. Okay, so for example, one more I will take some function of, for f of x we are having the curve. Okay, actually integration is nothing but antiderivative of differentiation, antiderivative of differentiation, or inverse process of the differentiation. You can say integration is nothing but what, integration is nothing but inverse process of differentiation, or you can say that antiderivative, not anti, it is antiderivative. Okay, antiderivative, this is how we are calculating the integration. Okay, one example I will give. For example, you cannot say the plot area is x square by 2 plus c some c. Okay, so this is nothing but what, integration of x dx. Okay, integration of x dx is nothing but x square by 2 plus c. C is nothing but integration constant. That is, integration constant is nothing but arbitrary constant. It is arbitrary constant. So value of that c may change problem to problem. Okay, that is nothing but. Okay, now it is not you cannot say the area of the plot or area of the some field integration of x dx, or you cannot say for to sum on x square by 2 plus c is the area. So if I give like this 0 to 1, lower to upper, so that is x dx. If I take like this, what is the integration of this x? So it will be x square by 2. So here 0 to 1 you can take, plus some this one c, integration constant c. So you can evaluate here only. This is nothing but what, you will get here 0 by 2 is 0 only. So this will nothing but, you will get the value here 1 by 2. How to make this one? You have to write x square, you have to put once 0 and once 1. Okay, so first 1 and 2. So this will, you will get the value 1 by 2. So this 1 by 2 is nothing but, suppose if I put in the graph like this, so this is 0, some straight line is there for x, so y is equal to f of x. So like this you will get, it is 1. So this point is nothing but 1 comma 1. So the shaded region of this one is nothing but what, 1 by 2. So this is nothing but your right angle triangle. So if I solve by the right angle triangle formula, half into base into height, this is 1 and this is also 1, half into 1 into 1, that is nothing but again half will be there. So like that you can take this one. Okay, like that you can remember. Okay, so here integration of x with respect to this x is nothing but x square by 2 plus c. Suppose if I solve this one, again you will get what? This, the derivative of, now you can take this one, derivative of, what is that? Derivative of x square by 2 is there now. So derivative of this one if you make, okay, what happens? D by dx. So what happens? This one, x square is 2x by 2. So here if you make, you will get what? X. The derivative of this, you will get what? X. Okay, so integration means a inverse process or reverse process of differentiation is nothing but integration, you can say. So if you make the derivative of this one, again you will get this one. Okay, so few words I want to tell you to remember. You can remember the few words. So if I write here integration of f of x dx, so this can be said at integral of f with respect to x, Suppose if I tell f of x in integration of f of x dx, we can say that it is integrand. Means here f of x in this one is integrand, you can say integrand, this is d, okay, integrand. So suppose x in integration of f of x dx is nothing but what here? Variable of integration, you can say variable of integration, you can remember. So integrate means what? Suppose if I give the word integrate means find the integral, okay. Next you can say that integration means the process of finding the integral, and constant of integration means any real number c considered as constant function, and integral of f means f dash of x is equal to f of x. So these are very important, you can remember. Okay, thank you.